up. Okay, so we have red dots kind of everywhere. So let's go through this. To solve a quadratic equation, so this is a quadratic equation. It's an equation because it has an equal sign. It's quadratic because x is squared. Okay, this is a power of 2 right here. One way to solve these is by completing the square. And so here is an entirely worked out example of that. To solve this, we are going to think about what number can we add, okay, on both sides, because we want to be able to complete the square. So x squared plus 10x plus something will give me a factored product of binomials. So right here, x squared plus 10x plus 25 is a perfect square trinomial. Putting a 25 here will make it so this just turns into x plus 5 squared. Now, the reason we figure out it's 25, okay, what number do we put? What you have to do is take the 10, which is in front of the x term, the single x. You take that number, you take half of it, and then you square it. And so that's what they're showing here. They took 10, they took half of it, and they squared it. I wrote it a little bit differently last week. I had this as just a single fraction, but this means the same thing. Half of 10 is 5. 5 squared is 5 times 5, 25. So that's why we're adding 25 here, so we can complete the square on the left. We're adding 25 on the right because whatever you do to one side of an equation, you have to do the other side. So x squared plus 10x plus 25 equals 1. These add together give us 1. This now, because it's a perfect square trinomial, can be rewritten as x plus 5 squared. The x and the 5 come from the fact that what did you square to get this term? To get x squared, I squared x. And then what did you square to get this term? To get 25, you square 5. That's why an x goes here and a 5 goes here. Then, because that is being squared, means you have 2 copies of x plus 5. To undo it, you take the square root. The square root of both sides, because we can't just take the square root of one side. Whatever you do to one side, you have to do to the other side. Make sure you keep your phone put away, okay? Thank you. Whenever you take the square root of a variable, okay, the x is in there, I took the square root, I have to add in this plus and minus. And so square root of 1 is 1. Square root of something squared is just that thing, x plus 5. And so from this point, you can break it into 2 equations. Okay, x plus 5 equals positive 1, x plus 5 equals negative 1. And you solve them, and then x is negative 4 and x is negative 6. Okay, so this is the method we were learning last week. I'm going to teach you a new method today that's going to let you solve any quadratic equation. Okay, quadratic means you have an x squared term, and it's an equation. It has an equal sign. Okay. So lesson 22.3, using the quadratic formula to solve equations. That's your learning goal for today and tomorrow, is that you can solve quadratic equations by using the quadratic formula. So what is that? This quadratic formula is a formula to find the values of x that solve any quadratic equation. Okay, the only restriction is a cannot be 0. If a was 0, 0 times x squared would be 0. You wouldn't have an x squared term. So you have to have an x squared term. This right here is a quadratic equation, and it's in standard form. The x squared term is first, the x term is in the middle, the c term is last, and then you have equals 0. If you can write it this way, then you can see A, B, and C are just numbers, okay? You'll figure out what they are and you just plug them into this thing right here. This thing looks crazy, right? There's all kinds of stuff happening. X equals negative B plus or minus the square root of B squared minus 4AC, all divided by 2A. So the B shows up twice, the A shows up twice, the C shows up once. But where does this even come from? This comes from completing the square, what we were doing before. We're just putting it in a very general form, so you don't have to do all those steps of completing the square. You would just figure out these three numbers, put them in here, and simplify this. Okay, and I want to show you where this comes from. Okay, because then maybe it'll make more sense of why we can use it. So I'm going to change how I'm presenting it here real quick.
How to derive quadratic formula. To do this, we're going to go back to our rules for completing the square. Well, the first step is we want to get the quadratic equation into the form of x squared plus dx equals g. If you've watched the other videos or seen this in books, you may see that we've used different variables to represent our constants. I did that so we wouldn't confuse the variables in the quadratic equation with the variables we use for the steps of completing the square. The first step is to get the constant in front of the x squared to equal 1. We will do this by dividing all the terms in the equation by a. And that would leave us 1x squared, or just x squared, plus bx over a plus c over a equals 0. We also need to get the c over a on the other side of the equation, and we'll do that by adding negative ca to both sides of the equation. Now I need to figure out what number I need to add to both sides to complete the square.
Real quick, so just looking at your screens, if you're on your Pear Deck tab and you want to go back to the Google Meet tab so you can see the video being played.
We're going to take 1/2 of the term in front of x, and we're going to square that. And that would leave us with b over 2a quantity squared. And I'll add that to both sides of the equation. On the right-hand side, I'm going to go ahead and multiply that out because I'd like to combine my two fractions. So I get b squared over 4a squared plus negative c over a. Before I can add those two terms, I have to have a common denominator. So what I'm going to do is to multiply both the numerator and the denominator of negative c over a by 4a. Now I have a common denominator of 4a squared. The next will be to factor the left-hand side, which gives me x plus b over 2a quantity squared. And on the right-hand side, I'm going to go ahead and complete the addition, and I will end up with b squared over 4ac divided by 4a squared. Next, I'm going to take the square root of both sides. On the left-hand side, I'll get x plus b over 2a is equal to the right-hand side, which is plus or minus the square root of both the top and the bottom of the fraction. The square root of 4a squared is 2a, so that'll be my denominator. Next step is to solve for x. So I want to subtract b over 2a from both sides of the equation. That would leave me with negative b over 2a plus or minus the square root b squared minus 4ac divided by 2a. Of course, I can combine those because I have a common denominator, and I get the quadratic equation in its traditional form. X is equal to negative b plus or minus the square root b squared minus 4ac divided by 2a. Not only is it fun to see where the quadratic formula came from, but this way, if you forget it, you can recreate it yourself.
Okay, so I was just showing you that so you can see where it came from. It looks really foreign if you didn't see like it's derived from that original equation, the general form. So I'm going to change how I'm presenting one more time. And so we're going to be using part of the quadratic equation called the discriminant. to determine the number of real solutions. So if you have a quadratic equation, ax squared plus bx plus c equals 0, it can have 2, 1, or no real solutions. Those are your possibilities. So far, we've been solving quadratics where we get 2 solutions for x. But you could also have 1 solution, and it could also be no solution. So the way you can find out before you even start plugging into this formula and solving it, if there is even a solution to find, is by looking at what's called the discriminant. And that's this part right here. It's the stuff under the radical sign. B squared minus 4 times A times C. You can see it's under the radical. Okay, it's just this part here underneath in the square root symbol. So if we're looking at that, if it turns out that b squared minus 4ac is a number greater than 0, it's a positive number, then there's going to be 2 solutions for x. If it turns out b squared minus 4ac is less than 0, it's a negative number. You cannot take the square root of a negative number, so there is no real solution when that happens. In later courses of math, you'll learn that you can create this imaginary number to start doing math equations that involve taking the square root of a negative number. You don't have to worry about that, okay? But if it's square root of a negative number right now, we say there's no real solutions. And so if you were asked to solve an equation and you look at the discriminant, it turns out to be a negative number, you'd be done. You would just write no real solutions. That's it. If it turns out b squared minus 4ac is equal to 0, these are the 3 possibilities: greater than 0, less than 0, or it is 0. The square root of 0 is 0. Plus or minus 0 is 0. So there's only one solution in this case. It's the same value of x. Okay, and so here's an example where that's shown how you can do that. Determine how many real solutions each quadratic equation has. X squared minus 4x plus 3 equals 0. Identify A, B, and C. So if just looking at that picture, we're looking at the number parts of our equation. You want to make sure it's in standard form, which it is in standard form. We have x squared. We have negative 4x. That's the x term. Then we have the constant term plus 3 equals, and 0 is on the other side by itself. So this is in standard form. Okay, and then what you can do is just look for the number parts that are in that equation. So in front of the x squared term, there is a coefficient. Even though you don't see it, it's invisible. It's a 1. So if you don't have it, you can draw it in. You put a 1 right there. And that's actually our first value that we need. That's what A is equal to. A is 1 because it's in front of the x squared term. Then you look for what's in front of the x term. You can see here there's a 4, but since it's subtraction, we have to include that subtraction in the value of B. So B is negative 4. The number by itself, that's the constant. And so C is 3. So that would be your first step here. You want to identify what's A, what's B, what's C. Then you're going to use the discriminant next. Okay, this is the discriminant right here. B squared minus 4ac. It's the stuff that's under the square root. The way you use it is you substitute those values into the discriminant. You substitute the values into the discriminant. And so we'll do that here. You can see they replace the B with what B is equal to, negative 4. They replace the A with what A is equal to, 1. Replace the C with what C is equal to, 3. And then you're going to simplify it. So right here, simplifying that, you want to use PEMDAS order. So they get 16, for -4 squared. They get 12 for 4 times 1 times 3. And then when you subtract 16 minus 12, you get 4. All right, 4 is a number that is greater than 0. Okay, 4 is greater than 0. So based off of what you have here, when you have a number greater than 0, there are 2 real solutions. Okay, so we're going to try this too with the second example. We're just going to fill in these boxes. So first thing we want to do, make sure it's in standard form. X squared minus 2x plus 2 equals 0. It's in standard form. So even though it doesn't say that, I'm going to add that in right here. Okay, if it was not in standard form, then you would want to rewrite it so that it is in standard form. All right, and then we're going to look for what is A, what is B, what is C. So A is whatever's in front of the x squared term. You don't see anything? Well, there's that invisible 1 there. So A is 1. Then we're going to figure out what B is. B is whatever number is in front of the x. If you see a subtraction sign, it belongs to that term. So B is not just 2, but -2. And then we'll figure out what C is. C is the constant, okay? The number by itself without an x. In this case, it is +2. All right, now we're going to use the discriminant. That's next. To use the discriminant, that's this thing right here. B squared minus 4AC. And so we're just going to substitute in the different values into it. All right, place the B with -2. We're going to replace the A with 1. Replace the C with 2. Next, we're going to simplify this, and we do want to remember to use PEMDAS order. And that's just the order of operations. E is for exponents. That's what we're going to deal with first, this exponent. -2 squared is the same as -2 times -2. So I get +4. And then we have subtraction and multiplication, but subtraction is last, so we're going to multiply before we subtract. 4 times 1 times 2. 4 times 1 is 4. 4 times 2 is 8. And then we're going to subtract. That's the last step. 4 minus 8. We're taking a larger number away from a smaller number, so it's going to be a negative. And the difference is 4. All right, so from that, I figured out that the discriminant is a negative number. If I look over here and look at what that means, if my discriminant is less than 0, well, there's no real solutions. I can't even solve this, okay? There's no real values of x that work to make this a true equation. So since it is less than 0, it has no real solutions. Okay, you can't take the square root of a negative number, and that's what we would be doing, because this is what would be under the square root symbol. This is what b squared minus 4ac is equal to. So when you're solving an equation, that's a quadratic equation, and you're trying to use the quadratic formula by evaluating your discriminant, you may find out that you can't even solve it, and then you just write that there's no real solution. I see some of you guys are still writing, so I'm going to leave that on student pace, and we're going to go to the next slide though. The other thing we're going to do with the quadratic formula is use it to solve equations, all right? And so all you have to do is check that your equation is in standard form. If it's not in standard form, rewrite it into standard form. And then substitute in the values of a, b, and c, okay? That's all you have to do. This is standard form, ax squared plus bx plus c equals 0. And then if it's that form, great. If it's not, make it in this form. Figure out what's a, what's b, what's c. And then you write this, x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And you replace the b's with that number. You replace the 2 a's with that number and the c with the constant. And then you just figure out what this is. Okay, so we're going to see what that looks like. This example is solved using the quadratic formula, 2x squared plus 3x minus 5 equals 0. We check that's in standard form. It is. So identify a. A is the number in front of the x squared term, 2. B is the number in front of the x term, 3. C is the constant. If it has a subtraction sign, it belongs to it, so it's negative 5. They wrote the quadratic formula. Then we substitute out the a's and put 2 in those places. We substitute out the b's and put 3's in those places. And you substitute out the c and put negative 5 in that place. Then you're going to simplify this. So, you know, where to start when you're simplifying? Start with the radican, because if it turns out that your discriminant is negative, you're done. You would just write no real solutions. If your discriminant is anything else, you can figure it out and solve it. So 3 squared is 9, minus 4 times 2 times negative 5. 4 times 2 is 8. 8 times 5 is 40. This subtraction sign and this negative sign turns into 9 plus 40, or 49, the square root of 49, which is 7. In the denominator, 2 times 2 is 4. Okay, and then they break apart into 2 equations, and they simplify it. And you get your 2 answers. So this is what we're going to practice on this slide. Okay, so I'm going to turn off student pace so everyone's on the same slide. And this is the equation that we're going to solve. 2x equals x squared minus 4. And so that first step is to make sure it is in standard form, and it's not right now, so we do need to rewrite it into standard form. Standard form means I have 0 by itself on one side of the equal sign, yeah? Oh, no. And I don't think there's really a point to go check one out right now because there's only like 15 minutes left of class. You can sit behind Bruno so you can see his screen. Bruno? Bruno, you awake? You want to do that? All right, so we're going to put this in standard form. 2x. I'll show you how they did it too, because it's not entirely clear how they went and did that. 2x is equal to x squared minus 4. So I need to get all the terms on one side and then just 0 on the other side. So since there's already 2 terms on the right, it's easiest to move that 2x to the right as well. And so whenever you move something to the other side, it basically just changes signs. Okay. And so this leaves us with 0 is equal to x squared minus 2x minus 4. And so you can take an equation and you can read it from left to right or right to left. 0 equals that quadratic, so that quadratic equals 0. So we could switch it around just like that. And then that shows us what's missing in that box. There needs to be a 2x in the box. What is that? Okay, now from that we can identify what's A, what's B, what's C. For A, we want to know what's in front of the x squared term. For B, we want to know what's in front of the x term. For C, what's the constant? Remember, if you don't see a number there, there is an invisible 1. Okay, so A is just 1. B is -2. And C is -4. So we just identified A, B, and C. And now we're going to use the quadratic formula, which is this guy here. We're going to replace the B's with -2. Okay, you have a B here. And a B here. So I need to write -2 in their spots. Now I'm going to replace the A with, that doesn't really work too well, does it? Replace the A with 1. Now we have another A down here. So I'm also going to have a 1 down here. And then the last letter I need to replace is C. C is -4. I'll put -4 in that box. Okay. Now we want to simplify what's underneath that square root symbol first. I'm going to come do that over here. Simplifying the radicand over here because they don't really show you what's happening, but I do want to show you. So to simplify the radicand, which is also called the discriminant, that's just this right here. -2 in parentheses squared minus 4 times 1 times -4. Okay, that's the discriminant. Discriminant is what we call what is under the radical sign. That is also called the radicand. It means the same thing, discriminant. And so I want to square -2. I'm going to get 4. I'm going to multiply 4 times 1 times -4, which is -16. Whenever you subtract a negative, it's like adding the opposite. So this just turns into 4 plus 16, which is just 20. Okay, 20 is a positive number, so that means I'm going to have 2 solutions to this problem. But when I look at the square root of 20, well, 20 is not a perfect square, so in order to simplify that, what I would have to do is, my sweater's stuck on my watch. Rewrite it as a product of 4 and 5 because 4 is a perfect square. So when I take the square root of 4, I get 2, but I'm still left with the square root of 5. So 20 is actually equal to 2 times the square root of 5. Simplifying this, I could factor 2 out of those 2 terms and then divide it with the 2 in the denominator. So what I'm really left with is 1 plus or minus the square root of 5. So x has 2 possible solutions here. It could be 1 plus the square root of 5 or 1 minus the square root of 5. And so those are the exact answers. Those are exactly the solutions. The square root of 5 is an irrational number. So if I leave it as that, then it's exact. As soon as I try to round it, it's going to be an approximation. So it's also asking for those approximate values, which I'll show you on a calculator. If I put in 1 plus the square root of 5 equals, I'm going to get about 3 decimal 236 because they want you to go to 3 decimal places. And the other possible answer is 1 minus the square root of 5 negative 1 and 2, 3, 6. Okay, so use the calculator to help you. That's totally fine. And those are my 2 approximate values. Notice when you round, you switch from an equal sign to an approximately equal to sign. So these are the 2 possible answers. And that's it.